Thank you. Good morning, everybody. Good morning, everybody. Thank you very much. It's an honor to be here again. Um, Thank you for the introduction, Jessica. Like she said, we've been doing this for quite a while now. It's interesting to be 2023. I don't want to dive deep into some of the things she said, but yeah, tech has really changed, and part of the things I'll be talking about are still new changes, okay? The evolution is going to continue. If you follow me on LinkedIn very well, I'm always talking about new changes every time. Um, I'm the annoying guy who doesn't want you to rest, because the truth is Africa and Nigeria needs to really be at par with the world so that we are not left behind. Thank you. Left and right, okay. Okay, so the topic of this conference is modern DevOps, okay? So obviously what I'm going to talk about is something around modern DevOps, okay? Something that answers questions of modern DevOps. DevOps has been something that has been there for a very long time. I was in a conversation with someone asked me, how old is DevOps? I said, DevOps is almost 20 years old. And the person said, how? I said, it's almost 20 years old. Because it's a buzzword you heard 4 years ago, doesn't mean it has not been there. I hope you know AI has been a concept for the past 40 years. A lot of people don't know. They think because they hear AI 4 years ago, it's something that is a buzzword. People not in tech will say, these people have come with a new word. AI has been there for over 40 years. There have been research papers. If you read very well, you hear that people have been talking about it. But the problem is always what? The times are not ready for the technology. So because the time is not ready, the technology cannot flourish. It cannot implement. It cannot grow. It cannot scale. Same thing with every other concept. Most of the concepts you see in technology, nothing came out from someone just wishing and thinking and then comes up with a new name that he likes. Some people think DevOps is a name that someone forged. Very unfortunate. Okay, that's not what I'm here to talk about. I and I used to argue about DevOps and culture a lot, but that's not what I'm here for. Okay, so today my topic is DevOps on the edge. Welcome, platform engineering. How many of us have heard of platform engineering before? Platform engineering. Okay. Still the same problem. People think it's a buzzword. It's not a buzzword. There's always this perception that everything is a buzzword. Every new word you see on the internet is trying to solve a problem. And some people are behind it, driving that change that is supposed to happen. Just the way somebody came up with ChatGPT-3, and everybody's trying to build a chatbot that uses LLM. There's BARD. And so many other names are coming out. Why? Because someone is trying to lead that change. I guess it's no longer a buzzword, but I'm not here to talk about that. Okay. This guy. Help technical team. Okay. So, these are the things I'll be talking about. What is the problem? What is the problem that platform engineering is trying to solve? Okay? Before we call it a buzzword, what is it trying to solve? Why is it even coming out? Did somebody just wake up at night and just felt good and say, okay, let's call this thing platform engineering and let it just be a platform? And let's throw away, I see a lot of articles online saying no DevOps. Let's throw away DevOps and bring a new word. No, that's not the purpose, please. I'm not here to say DevOps is dead. Please, I'm not in that school of thought. Okay? DevOps is not going to die. DevOps will only evolve. But the concept and the principles will continue to remain. I was in a long argument with someone, a CEO, a couple of weeks ago, and the person kept on telling me, with AI, what do you think will happen to DevOps? I said, nothing will happen. And he said, it's a lie. What are you trying to tell me? I said, DevOps is not Jenkins. That's what I told him. I said, the problem people have is that you think DevOps, once you do Jenkins, you say you are a DevOps engineer. Once you set up Kubernetes, you say you're a DevOps engineer. That's not what DevOps is about. I said, do you know there is DevOps without tools? And then the person is like, how? I said, yes. It's the concept, it's the principle. These things are just tools that help you to deliver that value faster and better. It's the concept and the process that matters first before you bring in the tools. That's why if you work with people a lot, you see that people who don't understand principles, when you give them tools, they are confused. They don't know what to do with it because they obviously don't understand the principles of what should be done. But if you understand the principles, when you take any tool, you will know the input and the output, what you are expected to do. Okay, let's leave that. The problem, how can it be better? What's the implementation and the pros and the cons? Everything has advantages and disadvantages. Nothing is a silver bullet. Okay, yesterday is history. Tomorrow, a mystery. Today is a gift. That's why we call it the present. Okay, let's move forward. Let's go to the problem. Now, what is the problem? What is he trying to solve? Somebody's moving my slide there. Okay, now, what is the problem that platform engineering is trying to solve? If you're a DevOps engineer, some of these problems I'm going to mention, you should be very used to it. Very, very used to it. Issue number one is, in DevOps of today, developers still share code for DevOps engineers to deploy. True or false? There is still a barrier where things are thrown over the wall. Now, if you remember, DevOps was saying that, if you read all the beautiful videos on YouTube, they'll put a wall, and then they'll say with DevOps, the wall is not there. Is that true? Are you sure? Okay. Personally, I don't think it's true. Because it still happens that developers write code, and they say, this is the repo. Go and deploy it. Still the same thing happening. The only difference is there is a trust on infrastructure. Before, there was no trust. You and the developers have to do everything together. Now there is some trust in infrastructure. It's okay, let's give you benefit of that you will do this thing right. But there is still that case of the developers are folding their hands and asking you, is it deployed? Is it ready? Give me URL. I want URL. Give me URL. Still happens. True or false? Now, the second problem is developers and DevOps engineers do not have a 360 view of a service. Repo details, service dependencies, observability systems, and even endpoints. There are some businesses where developers don't even have access to the monitoring dashboard because they don't care. It's as simple as that. And unfortunately, in the rules of SRE, the first point of call for debugging is actually from the developer's end, not even from the infrastructure end. Because 70% of the problems that happen in applications are usually code-related. Okay? So if you do not know what is going on with the system as an engineer, you are going to be blind to what is going on every time. And what's going to happen? You are going to burn out that your DevOps engineer, because if anything shakes in the system, you are calling him. Even if a bird flies and nothing happens, you are still going to call him. Whether it's your business or not, you will still call him. That's issue number 2. Let's talk about another issue that occurs. Next slide. Okay. Different deployment method across different teams. Who has experienced this before? Okay. This might not be very common here because most of the teams we have locally are small teams. Now, for very large organizations, I've been in an organization where we were about 3,000. And in the 3,000 organization, every, let me use the technical word, every scrum team was about 25 people. So imagine a scrum team of 25 people multiplied by 10. I'm talking about 250 teams in an organization. Each team has an engineering manager. That's power. They practically handled setup and deployments. So if you go into how these people deploy, trust me, everybody does what they prefer. You see this guy doing trunk-based deployment method. You see this guy doing branching strategy deployment. You see this guy telling you that, you know all this your Kubernetes, I hate it. I like my VM. I will log in and I will deploy, I'm happy. The guy will say, don't worry, I know how to do service restarts. I will do service restarts. Do you understand? That's what happens. I personally have seen this happen. It's very chaotic. You will hate, in short, you will not even know what you are hired there for. You just be looking at everybody and asking yourself, what's going on? Like, is it that everybody is here to do their own? Let me be doing my own. And then there will not be some, maybe like 3 scrum teams that are like, okay, we like you, we hired you to solve the problem for these 250 people. And you're like, how? You know? So that's another problem. Agile teams perform infrastructure provision in CI/CD monitoring in different ways. And you know one problem people on these organizations always have? They always have very high costs, very high, because everybody is setting up the way they like. You see one person setting up a 128 gig RAM, and they are using only 400 MB RAM on that machine. And you're asking yourself, what's going on? Do you understand? So it becomes very chaotic. Trust me, if you are privileged to work in a team, a company that have over 1,000 staff, you see this thing happen a lot. It's very common. And if you are now very unfortunate that some of these engineering managers have little infrastructure experience, that's the end. There's nothing you will tell them they will listen to you. They will never listen to you. Okay? What happened? Okay. Do we have another problem again? Yeah. System resources as services are scattered across disparate systems. It piggybacks on the previous point I just made. Now, you now have different tools. Okay? This person says, I like Grafana. This person will say, I like Elasticsearch. This person will say, I prefer CloudWatch. This person will say, I like Prometheus. This person will say, I prefer SysDig. This person will say, I like. What's going to happen? You're going to have an organization that have over 300 services. That's what's going to happen. Different logins and systems that require multiple tabs to monitor and view. It becomes very chaotic. And you know what is so annoying about systems like this? When there's a problem, you are the first person they call. And trust me, you've never seen that system in your life before. And they're like, this system is done, go and fix it. And you're like, which system, where? When I have 300 tools in this company, where am I going to start from? Okay. So these are some of the identified problems that we currently have as DevOps engineers or working in a company where we employ DevOps processes. The next question is, how can it be better? Please mark me, I didn't say this is the solution. I'm just saying, how can it be better? Because we are looking for one button to solve all our problems. It's not possible. Okay, how can it be better? Next slide. Hello, platform engineering. Now, this concept of platform engineering is supposed to solve some of these problems I identified. Not all of them, but some of them, to an extent. Now, a platform engineering system is actually a self-service PaaS that enables engineers orchestrate and deploy without a DevOps engineer. Okay? It's a self-service, I'll break down each word. Self-service PaaS. We know what a PaaS is, platform as a service. When you say self-service, it means I don't need to be there. If you want to open Facebook, do you call Mark? No. You open Facebook. That's self-service. You want to create an email address, you call Sergey Brin and Larry Page and say, please, I want to open Gmail. Please, can you come and show me where to write my name? You don't do that. That's what we call a self-service platform. Now, it enables engineers orchestrate and deploy. Most of the time as infrastructure, the first thing you are doing, you are trying to set up your environment and then deploy your systems. The platform engineering systems also help you with that. Without a DevOps engineer, just imagine you wake up one morning as a DevOps engineer, and the next thing you see is you just see notifications, and you don't have to do anything. Please, won't life be sweet for you? Please, life will be sweet for me if it's not sweet for you. You know? Okay, so that's what platform engineering is supposed to solve. That is what it is supposed to solve. Please, mark my words very well. But we all know that all these things are not cast in stone. And like I said, platform as a service means that I can give an engineer platform.company.com. And when they go there, everything you need as an engineer to deploy and set up an application is already there waiting for you. And you go, and you move on with your job. Now, how does it do that? Okay. These are the 5 major things that we need to get done to operate any system. Okay? To manage and operate any system. The first thing you do is you create the infrastructure that goes with it. Whether you are doing ClickOps, you are doing infrastructure as code, whatever one you are doing, you have to create the infrastructure that goes with it. The next thing is creation of the repo. Different businesses have different ways of creating repo. Add branch rules, repo configurations, permissions for the repositories. Then you have CI/CD configuration. I know a lot of us here know CI/CD very well, so I don't want to go deep into that. I mean, how you deploy. Everybody has their own method of deployment. Whether you are doing pull, push, Argo CD, whatever technique you want to use. And then you have the security setup, which has to do with DAST, SAST, security after deployment, image scans, your Trivy, every other thing that has to do with that. And then your observability. This is another very big section. Logging, monitoring, metrics, tracing. This section is becoming very big. Maybe one day I'll talk about observability as a separate topic because it's actually getting bigger than it used to be. Okay. Now, how do we implement this? Now, from the previous slide, the goal is when you have your platform set up, okay, those 5 things, you don't do them manually anymore. That's the plan. That's the goal. Because what still happens till today is when an engineer is done, those 5 steps, you have to do them. The best you can do is copy and paste. That's the fastest you have. Okay, you've done it for this project. You just copy everything and paste it here and run it. You copy and paste. But look at the time it takes to copy and paste than the time it takes for you to do nothing and allow an engineer to do it. Okay? So it can make the difference between the number of time, how many hours you have to sleep and stay awake. Now, we're talking about the implementation of platform systems. Okay? Now, that makes something called a platform that a platform engineer works with. One of them is what we call the IDP, or the Internal Developer Platform, or Internal Developer Portal. Some people call it platform or portal. What is this? This is just the beautiful dashboard that gives the engineer the interface to say, you want to create a service. What's the name of this service? Payment service. Fine. You write the name of the service. And then they click on create. Now, when they do that, a lot of things happen in the back end. Those 5 operations I just mentioned to you are automatically orchestrated in the back end for the engineer. So whenever that developer performs any change to their code, they don't have to say, oh, DevOps engineer, I'm done with my changes, so can you deploy my code? No. That interface, that developer platform, shows the engineer that when you push your code to branch A, it's going to build. When you build, I will show you the build here. When it deploys, I will show you deployment. When it deploys, I will show you the URL here. You don't need to talk to anybody. That's what the IDP does. That's why one of the problems I mentioned initially was 360 view of a service. So the IDP gives you 360 view of a service. So imagine you're a new engineer in a company. The first problem you always have is you don't know where things are. You have to find your way. You have to strut your way. You have to read a lot of stuff to know. With an IDP, you don't need that. You just go to your IDP portal, you open a service, you know the last person that made a change, you know the last successful deployment, you know the URL of the repository, you know the URL of the application, you know the people in charge of the application, you know where the application is deployed to, you know how the application is running in that environment, and every other thing you need at that point in time. Trust me, your day will be very sweet on the first day at work. That's what an IDP is supposed to do for you. The next thing is the service catalog. This is just a placeholder name. Service catalog basically is what gives you the list of services you have in your IDP portal. Okay? So this is where you definitely manage the life cycle of every particular service. I don't know if service is the right name to call it anymore because these things are getting bigger. Okay? The platform orchestrator. Now, this is also peculiar to certain platform engineering businesses, okay, where we have something called a platform orchestrator. What this orchestrator does is that it helps to manage those 5 operations I talked about. I mentioned orchestration, CI/CD, security, and 2 other things. So the orchestrator helps to manage all those operations in the background. Don't forget, the goal of the platform for a platform engineer is to give the developer a one-click pass solution to set up, deployment, security, observability, and monitoring. All you need to do as a DevOps guy is just to fold your hand and watch everything work. That's supposed to be your job. So DevOps lounging, that's the goal. Yeah, we should lounge. We have suffered enough. Okay, sleepless nights. Okay, and then plugins and integrations. Obviously, your platform is just a platform. Okay? It needs to plug into certain other systems. Trust me, most of the systems you are going to be working with are already existing systems, like GitHub, okay? Like Grafana, like AWS. They are already existing systems. So the platform system needs to perform some kind of integrations, and you need to have plugins that can help you communicate with these disparate systems, aggregate this data, aggregate these metrics, aggregate this flowing system updates back into your IDP so that your developer can see everything in a single view. Let's go. Okay. So, now to tools. I like to talk about process before tools. Okay. So these are the most common platform systems that exist. How many of us have heard of AWS Proton before? Proton. Okay. One person. It's a very rare tool people talk about, but it's there. So AWS Proton is AWS' first approach at platform engineering. If you go to Proton at first, you will not like the service. But trust me, after understanding today, you will love the service and what it does. It's practically a very basic example of a platform system. Okay? Although at the moment it is not, it's not doing what people usually do. What I mean by that is the kind of services people use. Proton is not catering for it at the moment. It's mostly catering for Fargate and Lambda services. Okay? But it does the job, which is one-click setup, one-click orchestration, one-click management, and one-click operation. Okay? So in Proton dashboard, you can give an engineer this URL, and they will create their service. They will put the Git URL, and they click on it. It will create the environment, create the orchestration, create the pipeline, not without you, deploy the application, and generate the URL for the application and share it with the developer. Everything in a single blow. AWS Proton can do that for you. But like I said, at the moment, it supports Fargate and Lambda. But you can actually write your own template if you want to. So, but I don't know if I have time for that. Okay. There's Backstage. So Backstage is from Spotify. So Spotify is one of the drivers of platform engineering because they were able to make it work. Okay? So in Spotify today, if you get hired in Spotify, I'm sure that as a developer, you don't even have to talk to anybody. You just go to the Backstage UI, and every single service that they have in Spotify is there. And another good thing about platforms that I didn't talk about is also permissions. There are certain services you don't want everybody to have access to. AG, billing. Obviously, everybody should have access to billing. Maybe only top engineering team managers. Okay? So the services you need to have access to work with as an engineer, you just see them there. And I mean, it just makes your life very easy. If you want to start working on a service today, you don't need to ask so many questions. Okay? Some services go to the extent of when you type in the name of the service, they're going to ask you what programming language do you want it to work with. You select the language, it generates a boilerplate code, generates a boilerplate pipeline, and deploys it for you without any DevOps engineer being involved. That's the goal. Okay? And then you have Humanitech, one of my favorites. Okay? And then you have Configurate. Go to the next slide. Humanitech has something pretty amazing. Humanitech builds and, what should I call it? Platform as a code. Okay, that's what they built. Yeah. Platform as a code. So if you look at this script, it does everything you need in a single script. If you look at it very well, the first thing it does is that you name your service. That's the metadata name. And then you start putting in the things that your service needs. You have identified the language. It's a Node.js, okay? And then the variables you need. You can see Redis is there. And then at the bottom, it's creating the Redis and the DNS. And then the port. So what this script is going to do for you is, number one, it's going to create a repository for you. Number two, it's going to create a Redis instance for you. Number three, it's going to connect your application, your Redis instance to your application. It's going to deploy your application, and you have a URL that you just open, and your page is ready to load. What's better than that? Okay? But this service is from Humanitech. Okay? So you can check out Humanitech. It's pretty cool. Pretty straightforward to use. This is just a sample. If you go to their website, you can see other samples you can generate. You can generate something like this for Java and Postgres. You can generate for different samples. But this is just showing you an example an idea, a concept of what platform systems are going towards. It's not just IAC for AWS or CI/CD for GitHub Actions or what should I call it again? JSON for, should I say, Grafana, okay? You have a single system that will help you to plug all this in and manage them as a single entity, making your work easier as a DevOps engineer, making the life of the engineer faster, and making them more efficient in work. Just imagine after a whole week, your phone never rings or you never get a Slack message for any problem. Because whenever they see a problem, they get a notification, they see the logs, they fix it, they push, they fix it, they see the problem, they fix. I hope they don't sack you from the job. Okay. All right. So, everything that has a positive has a negative side. Always. I'm not going to excite us that this thing is a silver bullet. No. It has its negative side. Let's look at the pros and the cons quickly. The first positive thing about a platform is that orchestration of infrastructure is coordinated from a single source. Okay? How many of you are bored with Terraform? I'm bored with Terraform, though. Maybe everybody's not like me, but I'm bored with Terraform. Okay, now, the code I just showed you is going to have, obviously, some Terraform under it. Whether you want to use Pulumi, Terraform, CloudFormation, CDK, there's this argument between CDK, Pulumi, and Terraform. It's just a crazy argument. I'm not going to talk about that. Okay, so, everything happens from a single place. What does that help you with? Single source of truth. Easy to debug. Faster to reiterate. The next thing is faster onboarding of new engineers because the platform has 360 view of services. Like I said, a single place you can see every single thing happening. In short, just imagine you go to work the first day and you don't need to ask anybody for anything. You don't even need to read documentation. As you're looking at the dashboard, a commit just comes in, and then you see the pipeline running. You see the URL of the application. You see the pull requests. Everything from a single place. You don't have to go to GitHub. From GitHub, you click one tab, go to GitHub Actions. From GitHub Actions, you click on that tab, you go to Grafana. From Grafana, you click on that tab. AWS, it will give you sign-in, type OTP. Type OTP code. As you're looking at that one, the pipeline is still running. You want to go and check if the pipeline is not running. You switch again 3 tabs back. Before you know, you have 20 tabs open, 5 browsers. That's our reality now. So this is supposed to help us solve that problem. If I open payment service, I should see everything about payment service once. From the deployment to code history to whether failed or successful deployments, URLs, how everything connects in the system. And then it eventually improves developer productivity, which is where we are going to. We want to make developers better. You understand? They are our customers. If they are happy, we are happy, everybody's happy. That's the goal. So if an engineer does not need to wait for me to copy the deployment code and paste it and run it and tell him, okay, I've deployed it too. You understand? Let me not say what I want to say. Okay, but I'm sure you understand my point. It eventually increased developer productivity because you don't want to be the one holding the deployment till the next day and they say you are the one just because you forgot to copy and paste and save and push. So let's go to the cons. So it could have a negative domino effect. Now, just imagine the number of integrations you need to have a holistic view of a single service. Mostly when that service is using 7 other or 10 other dependencies. Okay? Now, let's talk about a single payment service. That payment service might be using an endpoint monitoring tool that helps you to check endpoints. It might be using an observability tool that helps you to check traces, logs, and everything. It might be using another tool for security scan. It might be using another tool for IAC, let's say Terraform. It might be using another tool for pipelines. Now, just imagine 5 of these services have a problem at the same time. Nothing is going to work on your dashboard. eventually. So what happens? You have to start going back to these individual services one at a time. Because everything starts from the infrastructure orchestration to the deployment of the service. So if anything happens anywhere, at any point on this flow, everything will fall like a pack of cards. So if you need to build your own IDP, you need to think about this very well. Because there is also the debate where people are building their own IDPs or people are using existing IDPs. I mentioned some existing IDPs. Some people have decided to build their own. It's not very difficult, but there are certain things you might miss along the way. Like I said, failover. So you need to build in failover into your IDP, your internal IDP that you use, your internal developer platform that your developers will use. You need to build in resilience into it so that they don't get frustrated. And then the second thing is management of multiple third-party integrations and security configurations. Because you have so many things connecting, you might miss some things. You might misconfigure some things. You might forget to rotate one key somewhere. You might forget to change one password somewhere, which is a security threat to your entire system. So these are common problems for systems that serve as one-size-fits-all solution. Because as much as it gives you a holistic 360 view of everything, you need to manage these connectivities and integrations you are making with existing systems that already have their own way of managing these things. So you need to build in and extend this extensible way of managing security availability into your new IDP that you're trying to work with. So those are the complications and the complexities of running an IDP by yourself. Okay, my conclusion is this. Tools are what we use as engineers. Tools do not use us. We use the tools to deliver value efficiently. Thank you. I guess it's time for questions, right? Okay, questions. Any questions? There are many questions. Okay. Okay, I want to give them the mic. So those are my two books. You can get them from Amazon. Infrastructure Monitoring and Dictionary. Thank you.
All right, thank you very much for that awesome presentation. I learned a few things. First question I wanted to ask, you mentioned AWS Proton. I'm madly familiar with it, but I'm not familiar with Elastic Beanstalk and Lightsail. How does it compare? That's the first question. Then you mentioned the IDP, and the first thing that came to my mind was scalability. How do these systems cope well when in where you need high scalability? Yeah, thank you.
All right. Let me answer it one after the other.
I think before you answer his first question, maybe I can merge mine so that you take it together.
Merge
yes.
the PR.
Yeah.
Merge the PR.
So, thank you very much for that session. It was a very interesting one. So my question is, from the sample orchestration code you showed the other time, it seemed very much similar to a Kubernetes manifest, like the API version, metadata, even the old, more like the old template, the old YAML file. So, and then Kubernetes, as we know, is a container orchestration tool. And you've been talking so much about an automated orchestration tool here in platform engineering. So I'm trying to draw so many similarities. And at the same time, I'm trying to see, are there differences between what we know as platform engineering or what you've explained to us as platform engineering and Kubernetes as a container orchestration tool, and the all works. Thank you.
All right. So that I don't forget his question very well. He talked about scalability of IDPs. So the simple silver bullet is just to use a third-party service. Okay? I tried to set up Backstage. It takes a while. Backstage is said to be the most flexible. If you Google it out there, Backstage is open source, it's very flexible. But man, the setup is a bit tricky. I like very clean setups. I'm sorry. When the setup is very clean, I like it. One-liners. Once you start giving me so many bash, I don't like it. Not that I can't do it, but I'm looking at what in AWS we call operational excellence. How can I transfer this to the next person? How easy is it for 10 people to do this same thing without making a mistake? If I'm going to run this thing in 10 different versions of Linux, am I going to have the same problem? Am I going to go from AMD to ARM? Those are the things that come to my head. So if I start seeing 20 lines, I just cut off. So that was the problem I had with Backstage. But people use Backstage. But the simple answer to your question of scalability is just that I didn't have enough time. Something happened over the week, so I couldn't. I wanted to do a demo on Configure8. You'd have seen it in action. You would have loved it. Trust me. If you use, I advise everybody here to try Configure8. It's simple. It's easy to use. It's free. Configure8.io. It's easy to use. It's free. There's another tool I found out, getports.io. Also very nice. These tools are just, once you sign up, they just give you a demo dashboard. So all this I'm saying, you just see it. So it's left for you to perform your own integrations. For example, if you wanted to talk to GitHub, just generate your Git personal access token and put in. And they'll pull everything from your GitHub. So they handle that for you. It becomes challenging when you build your own IDP. That's when the scalability, you have to now open your eyes. So for example, in Spotify, they have a product team for platform engineering. There's a whole product team. There are a set of engineers that work on the platform that manages the systems. And patience, you understand? But at that level, that is how you can operate. So when you have the people, obviously you can manage the scalability and security and everything that goes with it. But at the end of the day, the goal is the productivity of the engineer and the speed of delivery. So it means that just the way the business, Spotify is trying to build better streaming service for music, they're also trying to build better platform engineering systems for developers to deploy more efficiently. Do you understand? Look at build time. How are we doing with build time? Okay, they are not going to go to GitHub Actions to fix the build time. It's the developers that will see it in the IDP that, build time has dropped from 30 seconds to 20 seconds. That mindset. You are trying to remove developers more from infrastructure. They should not worry about infrastructure anymore. They should just focus on their code and push. The magic that happens at the back is not their business. That's the goal. I hope I answered the question. No. So, Beanstalk is a PaaS. Beanstalk is a platform as a service. Beanstalk and Heroku are in the same category. If you don't know anything about infrastructure, you just want to deploy code, you just zip it and upload, and you are happy. When you are doing Elastic Beanstalk, you don't know anything about subnets. You have no business with VPC. You have no business with internet gateway. You have no business to know what a CIDR block is. You have no business with that. You just want to upload your code and move on. If they hack you tomorrow, you cry, clean your eyes, and you move on. You will not know why you were hacked. That's Elastic Beanstalk. Do you understand? And then, what other service did you mention? Lightsail. Oh. Lightsail. Do you know DigitalOcean? Do you know DigitalOcean? Do you know Linode? Okay. DigitalOcean, Linode, and Lightsail, they are in the same category. Cheap, quick virtual machine. Cheap, quick virtual machine. I did an article on it a couple of months ago and a video on it. Cheap, quick virtual machine. If you don't want to, I've seen somebody that said they hate the AWS console so much. I said, I agree with you. I said, no problem. Just use Lightsail and be happy. They said, so it can be simple. I said, yes, it can be simple. You just go there, click. It's $3.5 a month for the smallest server. And if you want a very structured billing, people hate AWS billing a lot because they see some numbers they don't understand. If you want them to charge you $5 a month in AWS, go and use Lightsail. They will charge you only $5. They won't charge you 5.01. Take it to the bank. That's what Lightsail does for you. That's what DigitalOcean does, and that's what Linode also does. So AWS just brought out Lightsail to compete in that market, in that space. But you don't even think about VPCs, you don't think about subnets, you don't think about... If they ask you tomorrow, you cry and you move on. Okay, so... all right. I've answered your question. Yes, so for your question, I don't think you should worry so much about syntax. I have a personal script I wrote like that too. Are you going to tell me it's Kubernetes too? I have a secret templating engine I have that I wrote. It's the same format I used. If I put that script in a code, It's able to connect with the secret manager, populate the code with the secret automatically, and deploy the code. You can't tell me it's Kubernetes now. Do you understand? So the whole idea of that template is if you know how an API works, an API, structured APIs, let me use that word, they have versions, okay? So Kubernetes just brought that to the marketplace, and everybody is adopting it. That's why you see that API version /v1. It gives people opportunity to be able to perform a lot of growth. So you can have V1 beta 1 while V1 is still running. You can have V2 so that there's backward compatibility. 2 years ago, Google dropped gcro.io. That's the registry where 90% of Kubernetes images exist. Do you know what happened? A lot of companies had major downtime. Why? Because of that version problem. If they had done gcro.0/v1 or /v, it would have been safer. But they needed to do a total, because according to them, they say they have been telling people, we want to remove this thing. People said, no, we are fine, So the purpose of that kind of templating you are seeing is for compatibility, okay? Extensibility. It has no business with Kubernetes. Because when I mentioned platform orchestrator, that if you carry that code on Kubernetes, it will throw error for you. To give you beautiful errors, because it doesn't exist. The right system that will understand it. Do you understand? So there's something called platform orchestrator in Humanitech that reads that code and orchestrates that platform. They even tell you to select provider. So all those Redis, Postgres, it will set it up for you automatically. So it's like infrastructure as code on steroids. You can teach a 4-year-old. You understand? Like, if I was going to write that in Terraform, do you know how long it would take? Do you know how many lines of code it would? Do you know how many things I have to worry about? Do you understand? But look at the Humanitech. It's just 20 lines. It will do the same job. For God's sake, who wants to suffer in this life? Okay. I hope I answered your question. I think there's one more question here.
Yeah. Thank you so much for the presentation. So my questions, I think I have 3 questions. Yeah. So, where's the need for the development?
Okay.
Yeah, so that's it. So, is it that platform engineering is actually with time, we take away the whole needs for DevOps engineer, or DevOps engineer will transform into infrastructure engineer, start maintaining the platform? So that's the first question.
Okay.
So the other question is entry, what's the minimum entry into platform engineering? Say I'm this guy that knows nothing about platform engineering, or I don't even know about cloud engineering, right? Do I just go and start learning Configurate, Humanitech, Backstage, and all of that, and I'll be good to go into the field of platform engineering? Okay. And also, do I need to have something like a software engineering background for me to become a platform engineer?
All right. This your question is what I've been trying to avoid. You know why? We like labels a lot. Labels are just labels. I'm sorry to say. I personally hate label. I was in a meet and greet someone said, what do you do? I said, I solve problems. He said, no. What kind of engineer are you? I said, God, what am I going to tell this person? Okay, I've done software engineering for 12 years. I'm doing cloud now for 6 years. I just told the person I solve problem. The person got tired of me. The truth is that, please, this presentation, the organizer, when we were talking, if he can talk here, he will tell you that we argued about this, my presentation. I specially, carefully crafted it like this. I can come and say, guys, DevOps is dead. This is the new thing. Platform engineering. Throw away your DevOps books and learn platform. That's wrong. Okay? Please, AI is coming. Will software engineers lose their jobs? You people are not confident. The answer is no. The answer is no, and I will tell you why. I will tell you why. Should I tell you why? Should I tell you what's going to happen? As with every evolution, 2 things happen. Is either you upskill or you are out. Those are the two options that exist. Okay? Now, that's why I love the name GitHub called it. What did they call it? Co-pilot. They did not say pilot. They called it what? Co-pilot. Look at that word very well. You are going to be working with AI. AI is not going to push you away. Let's understand that. So software engineers will not lose their jobs. But if you don't know how to work with AI, that is when you will start losing your job. That's it. Have you seen a human being that programmed the AI? Eh? Please, oh, it's not a human being. So why are we making it look like his spirits? Do you understand? I write on Medium a lot. Medium sent something to me recently, and they said, we want to start blocking ChatGPT from reading your articles. Come on, it's IP. How can I spend 2 weeks to write an article, and one boy in Hyderabad will just write something, will just copy my article and get the answer and paste it there, and they will give him PhD? Why? That's copyright infringements. So it's not going to be as easy for AI as people think it will be. There are going to be AI legislations. There are going to be AI laws. You can't just take AI and do what you like with it too. See what happened with data protection. And see how much Facebook paid. So it's not going to be business as usual. So to answer your question, it's not a versus, please. There's no DevOps engineer. Should I start learning what tools are platform? There's no tool for platform engineering, please. Because if you don't understand, I was talking to someone 2 days ago, we're talking about how we used to do deployments, where we'll log into a server, we'll clone the code, and we'll restart it. So, and then we started laughing. You know, I told the guy that I will never go back to that, and we laughed it off. But whether I like it or not, my understanding of those things helped my understanding of setting up a Kubernetes cluster with 700 containers, 1,000 pods. Trust me, if I didn't understand how a Linux OS works, I won't be able to manage things of that complexity. So what am I trying to say? Somebody cannot wake up today after secondary school and say, I want to be a platform engineer, and start looking for a book on platform engineering. You are deceiving yourself. You don't know Bash. You want to do platform. Why are you platforming to? Do you understand? So that's what happens a lot. People hear new buzzwords and want to flow with the tide of that buzzword. That's why when I was training in DevOps, I always had this problem. Every time, the person just wants to know everything about DevOps. You don't know TCP/IP stack, but you want to configure VPC. How? It's not possible. Best principles. That's why I said it from the beginning, that DevOps is not going anywhere. Remember I mentioned it. I reiterate, and I'm still reiterating it. Because all the gymnastics of platforms. Hey, he was asking me about orchestrator code. Please, if you don't understand YAML, can you write that script? Sure, you put everything in one line and think it's a textbook you're writing. Do you understand? I've worked with somebody who wrote YAML, everything in one line, and was running and said it's not working. And I'm like, what's going on here? Like, do you understand? So that's what sets you apart. AI will not chase anybody from their jobs. You just need to make sure you just need to make sure that you are not ignorant that it is there. See how it helps you become better and ride on that tide. Not say all this AI thing that they are saying. It's when you say that, that's when you will forget. It's just like in the days of system administration, everybody believed that was the best. In short, it started with Linux administration. Till today, if you meet Linux administration, they will tell you that all these DevOps, they are just playing. They will just be doing DevOps pipeline. Yeah, right? But how far? So, I've answered the questions. Is there another question I have? Another question? Sorry? Okay. So, any other questions? I think that's all. All right. Thank you very much.
Thank you very much, Ewere. Please, let's continue clapping. I mean, I'm not into DevOps, but I learned a lot. And like he said, somebody cannot just finish from school and just wake up and say, I want to go into DevOps.